Okay, so here's a simple example for a root mean square velocity. And if you've been having trouble with these problems, it's probably because of the units you're using, especially if you're in chemistry where you're used to using maybe a different value for the ideal gas constant or molar mass in grams. So the equation for root mean square velocity is the square root of 3 times the ideal gas constant R times the temperature, which is in Kelvin, and then divided by the molar mass. And in this case, since this is more of a physics problem than a chemistry problem, the molar mass has to be in kilograms. So I'll explain at the end of the video why these are actually the correct units. So just be really careful when you're using your units. So this ideal gas constant will always be given, and it's always the same, so we know that. The temperature we have in Celsius, so let's convert that to Kelvin. So 23 degrees Celsius. To get to Kelvin, you add on 273, so that would be 300 Kelvin. And then to get our molar mass, you can get that from the periodic table. So the molar mass for helium is 4 grams per mole. And we need to get that in kilograms per mole, so divide by 1,000 or just swing over the decimal place 3. So that would give you 0.004 kilograms per mole. And we should be good to go just to plug stuff in. So let's go ahead and do that. So root mean square velocity is the square root of 3 times ideal gas constant, 8.314, times the temperature in Kelvin, which we found was 300. And then the molar mass of 0.004 kilograms per mole. And you should be able to just toss this in your calculator and should come out to 1,368 meters per second. So there you go. All right, so to convince you that these are in fact the correct units, let me do that just for you real quick. So using the equation, essentially we just want to manipulate these units so that the unit of velocity comes out to be meters per second. So, I mean, you could use any of these, but you'd come out with a unit for velocity that doesn't make any sense. So that's why we really use these units. So the root mean square velocity is equal to the square root of, now the 3 we can just ignore since we're just looking at the units. So R is given in joules per mole Kelvin. So joule per moles times Kelvin. And then the unit for temperature is in Kelvin. And the unit of molar mass, I say we want it in kilograms per mole. So let me show you why that's correct. Well, if you've taken a physics class, you may remember that a joule is the amount of energy required to accelerate 1 kilogram over at a rate of 1 meter per second squared over a distance of 1 meter. So this unit is equal to a joule, and then we still have this moles Kelvin on the bottom here. So that's the first part, and then we're timesing that by the temperature in Kelvin. And then on bottom we still have kilograms per mole. All right, so that's kind of the expanded SI base unit form. So we're just going to start canceling some things. Well, kelvins cancel, moles cancel, kilograms cancel. So here you can see why it needs to be kilograms, not grams. And all we're left with is the square root of meters squared divided by seconds squared. And from here you can see that the square root of a square is just itself. So that would be the final unit of meters per second.